This time, to further analyze our logic circuits, we can use our knowledge of constructing or writing propositions and symbols and constructing truth tables to further analyze what will be the possible outputs of our logic circuit. So we have, for example, here we are asked to determine a proposition that is analogous to the diagram and construct a truth table to see all its possible outputs. So we have here the inputs labeled as P, Q, R, then we have our gates. So let's analyze what gates are we actually analyzing. So we have here P and Q as the inputs, then here we would be having our AND gate. The output of that would be an input along with R with the OR gate, and the output of the OR gate is negated by the NOT gate. So if we're going to take that into consideration, first, P and Q conjuncted because of the AND gate. And P and Q is the one, that output P and Q is the one that is disjuncted here in the OR gate, or with the input R. And this entire output would be now negated by the NOT gate. So we can see that one possible proposition that would be analogous to this circuit would be not P and Q or R. So now let's construct a truth table for this proposition so that we can see what are the possible outputs of this circuit. I'm going to use the alternative method. I'm going to have here PQ. Sorry, there should be R as well. So let's fix that. So we're going to have P, Q, R, then not P and Q or R. So for P, let's play out these values. For Q, these values, and for R, our alternating values. And we're going to input in the same. 4 ones first, then 4 zeros for P, twice alternating. That's just how I call it for Q, and then the one that is alternating for R. Now, since P and Q are the ones inside the parentheses, let's work with that first. Now I'm going to have 1 and 1, 1, 1 and 1, 1, 1 and 0, 0, 1 and 0, 0, 0, 0 and 1, 0, 0 and 0, 0. This is 0. Now the values in yellow will be now disjuncted with R. Let's have that in this color. So we're going to have 1 or 1, 1, 1 or 0, 1, 0 or 1, 1, 0 or 0, 0, 0 or 1, 1, 0 or 0, 0, 0 or 1, 1, 0 or 0, 0. Now, the value in red is what we would have to negate. So, not 1 is 0, not 1 is 0, not 1 is 0, not 0 is 1, not 1 is 0, not 0 is 1, not 1 is 0, not 0 is 1. So now we have our truth table for our propositions. Now what does this tell us? This is telling us that as if it's a switching network as well, that if we input all ones in our logic circuit, let's write that down. If we're going to have 1, 1, and 1 here, then what will come out here will be a 0 in our circuit. If we place all both ones in P but in R, we'll make it a 0, then what comes out here would still be 0. So the truth table is telling us what would be the possible output here in orange given the specific combination of inputs from the three starting points P, Q, and R. And that is how we can use a proposition to be an analogy to the diagram of the logic circuit and constructing a truth table as well to see all possible outputs.